And it's my pleasure to introduce Dr. Richard Vinci. And Dr. Vinci is the Director for the Center for Advanced Materials and Nanotechnology and the Professor, Department of Materials Science, Engineering at Lehigh University. And Dr. Vinci has published more than 70 technical papers and has co-authored an engineering textbook entitled Deformation and Fraction Mechanics and Engineering of Materials. It's my pleasure to introduce Dr. Vinci.
Thank you very much. We're running into the, it seems, somewhat iconic PC Mac unfriendliness. So the HP, which we heard a lot about in the last session, is going to rest up here. I'm going to go ahead with my trusty Mac here. So I'm here to talk about industry-university partnerships, and looking ahead in this academic session, I see a lot of really exciting looking talks talking about the teaching side of things. I'm going to shy away from that somewhat to give you a different flavor of how academia and industry can work together for mutual benefit. And just to give you a sense of my outlook and how I will be framing things, I wear two hats. So one hat is my departmental teaching hat. I'm a materials engineer by training. I look at the world through this lens of materials, and specifically I'm interested in things like mechanical properties. I'm interested in material selection and design. That's the side that I come from the teaching perspective. On the research side, I'm a specialist in mechanical properties. Again, I think a lot about materials. We are a PhD granting institution, so we have graduate students who are doing very high-level research.
Check zone 2.
Cutting-edge equipment to play with. And so a lot of what I'm going to be talking about is the second part, but as you'll see, we'll tread back into the teaching side as well. So when I think about the potential of industry and academic partnerships, I often think about the various roles that industry and academia can play and the benefits of their partnerships. All right, so what I intended to do here was, along the bottom here, I talked about the purpose of the interaction between academia and industry. It might be outreach, meaning K through 12, or community outreach, direct education and training of students, broadly defined, who students are, or R&D purposes. And on the left-hand side, I talked about who picks the topic of the interaction. And what I mean by that is, for instance, up at the top, the customer might be ultimately a third party. So the DoD might list a bunch of topics that they are interested in, and we together, academia and industry, go after those topics that are predefined for us. So that's what I mean by customer defined. Industry partner, if you are from industry and you have a problem you want to solve, obviously you define that topic. You come to academia and we talk about it together and try to come up with a solution. And finally, the bottom is where the college or the university is really defining the purpose and the outcome of the interaction. And then what I've tried to do here with these multicolored blocks is to identify the nature of the interaction. And in many cases, what I'm really talking about here is the funding source. But in some cases, I'm talking about the activity itself. So lots of three-letter acronyms, that sort of thing. I will not go through all of these, but my goal here in the next 20 minutes or so is to give you a number of examples of these different categories. If you have not had an academic industry interaction before, it might stimulate some thinking about the kinds of interactions that take place. If you have had these kind of interactions, there may be some others that you haven't thought about in the past. And hopefully this would lead to some increased commerce, shall we say, contact between some of the academic institutions in Northeast Pennsylvania and some of the terrific industries that we have who would be our partners. So I'm going to start with sort of the most obvious one that most people, I think about, and that's over here on the right-hand side. SP is sponsored projects. ILB, Industry Liaison Program. So here we're talking about a case where the industry partner has something they want done. Maybe they don't have the expertise or the tools to do it, and so they shop around and they discover that a college or the university has those tools. And so essentially what we're talking about, we organized the Industrial Liaison Program at Lehigh. sorry, the red is not showing up extremely well, but what it says there is that the industry partner sets the goals and provides the money, right? So in this case, you come, you pay, you get access to equipment, people, and this sort of thing. You don't want to dwell on this, because this is kind of an obvious one, and we're happy to chat with anyone who wants to talk about specific things. This is not a sales pitch, it's just an example. Moving ahead, on the far end of the scale now, if you will, is something like Lehigh's Summer Engineering Institute. It's one specific example of an outreach activity. The university is defining the activity, and we have industry sponsors. So the money comes from industry once again, but we're really serving a purely academic purpose. And so I want to use this example for a moment to talk about how additive manufacturing can be used to support an education and outreach activity with some assistance from industry. So I'll go through some specifics in this particular case. So Brian Slocum and I work closely together. We developed this particular activity. And in this particular activity, this is a part of a 4-week program for high school students. It occurs in July each year, about 50 students. 1 week is spent on additive topics. And what we do with these students is we take them all the way through from mechanical testing and analysis of pre-built parts to designing, building, and testing their own parts. Most of these students have not had experience with CAD, with finite element, and so we teach them the basics. And our scenario, you are part of, you're an intern for NASA. NASA is designing a 3D building capability for a Mars mission. When you get to Mars, you can't bring a machine shop, so when things break, you need to be able to print parts on the spot. So what is the polymer? What is the type of printer you're going to use? Are there some advantages and disadvantages to 3D printing? This is the approach that we take. So we made up this thing we call the Mars rover arm. It's on the lower left-hand side there. It's just a little box beam. I designed it. It's intentionally designed somewhat poorly, just so you know. If you're a designer and you look at that and you say, oh my God, I never would have designed that thing, good. Excellent. So what we do anyway with the students is we give them some background. They draw these things up with our guidance. So they have the basic one. We have printed a whole bunch of them ahead of time. We've chosen several different materials ahead of time. So the design is constant, the material is different. We also build in 2 different orientations so they can look at orientation effects. We have them do some finite element analysis that's shown up in the upper right-hand side and figure out where the conditions are worst. And we take them into the laboratory and the students test them. This year, for the first time, we're not only testing at room temperature, we're testing at Mars normal temperature, which, by the way, is about -75°C, which is exciting, right? So the students get in there, they break all of these things, which is fun. Sometimes parts fly around the room, which is extra fun, right? And then we all get together and we talk about them. They analyze the failures, they talk about what was good and what wasn't, what materials are sensitive to temperature and which are not, and so on and so forth. And then we send them out and they are supposed to redesign them to be lighter and yet stiffer and stronger than my lousy first design. So there's a not very imaginative redesign on the right-hand side. They got rid of some holes, they sort of rounded the edges. Here are some examples of some more imaginative designs that various students came up with. There were some even wackier ones, but this was some of them here. And I'll tell you what, when we go and we test them, some of them are like 100 times better than the original design. Some of them, by the way, are also 100 times worse, which is really sort of interesting. But I suggest this to you as an example of how additive manufacturing allows us, in the course of 1 week, actually 4 days, to take students through almost like a whole semester's worth of activity. Now, granted, it's at a shallow level, but they really get a sense of what engineers do in the course of this kind of activity. All right. So, all right, let me, that's the sort of the longest, biggest single chunk. Let me zip through some of these others now. So those were industry has an idea and has some money that it can spend. Or academia has an idea and begs for some money from industry that we can spend. But the real partnerships, of course, happen in between. So the rest of these are going to be true partnerships. And now I want to concentrate a little bit on sources of funds and what kinds of projects emerge from these kinds of funds. So undoubtedly, many of you are familiar with the SBIR and STTR funding processes. This is small business and tech transfer grants.
must be a small business to apply. The STTRs in particular require that you have a nonprofit partner that does a large fraction of the work. I think it's at least 30% of the work or something like that. And in fact, the university or the college can even lead the STTR. So these are topics defined by a third party, DOE, DoD, somebody like that. And they list them, and if you find the right partner, you go after these things together. So just to give you a sense of what we're talking about here and how often they come along, here's a list of DoD dates. We had one in April. There's another set coming in August. If you're interested in these things, they're all posted online. And we have one that we're just starting up with a company called Senvol, who some of you may know. Senvol is a data collection company. They gather loads of data about additive manufacturing processes. And what we would like to do with them over the course of the next year, or hopefully several years, is to couple their processes and their properties in a more predictive way than one can do now. Right now, it's a list of if you do this, you get that, but we don't know why. Right? So we're talking about software, predictive software that would allow you to take a set of processes and define what kind of properties you're going to get. So this is really pure R&D. Another example, we have a home-built wire-based, it's basically a welder on an arm printer at Lehigh for making large builds. This thing is open source since we built it, and so it has lots of opportunities for tweaking. And on the right-hand side, this is a regular ruler. You can see the size of this build, and this big thing here took only about 14 hours, and about 4 of that was pauses for cooling along the way. 14 hours to build something about, what's that, 16, almost 17 inches high out of metal is pretty impressive. So this is another STTR type topic, and specifically, I should point out that this is the beneficiary of many industry interactions along the way. So the university can only do certain portions of this by itself. So they worked, our mechanical engineers worked with eHarvest Systems under this thing called a ramp-up grant initially to get this thing off the ground. Lincoln Electric, another company, donated a $20,000 plus robotic welding head for this thing. And now they're in the midst of a proposal for STTR grant to put these things on Navy ships so that if you're out in the middle of the ocean and a large metallic part breaks, you can instantly build another one and put it into service. Will it be as good as the original? Undoubtedly not. But if you just need to get from the middle of the ocean to the port, right, where you can get a proper one installed, that might be worth it. Especially if you're in the middle of an activity of some sort that the military gets involved with, where sitting stalled in the middle of the ocean would be a really bad idea. So I also want to mention, by the way, Pennsylvania has been identified as an underserved state in terms of SBIR and STTR. And what that means is we don't submit enough proposals as a state. And so usually you start in phase 1, that's your first year of money. They're offering a phase 0 opportunity for small business in Pennsylvania, which essentially means there's a group of people here who will help you write a proposal. So if you're interested in this kind of thing, this is specifically through Department of Energy, but you might want to look it up online, this phase 0 assistance program, and see if it would be helpful. All right, zooming ahead here a little bit. The National Science Foundation, of course, also very interested in additive, but in a much more fundamental way. And a lot of National Science Foundation grants are very sciencey. They go straight to the college or the university. We do all the work ourselves, and that's sort of the end of it. But they do have 2 key programs that are all about industry interaction. One is called GOLI, and the other is this IUCRC. And I want to talk about the second one now, just to give you a specific example of what these things look like. So this is one that is hosted at Lehigh and also at Ohio State and Colorado School of Mines, University of Wisconsin, all joined together. IUCRC stands for Industry University Cooperative Research Center. And this is a list of all of the participants. I mean, this is an amazing list. And a lot of these are gigantic companies that have made very rich investments in additive manufacturing already. And the way that these things work is if you are a company that participates in one of these IUCRCs, there is an industrial advisory board that you participate in. So the company supplies some money, NSF supplies some money, academics and their industry partners suggest projects, and then the Industrial Advisory Board chooses those projects to move forward with. So industry helps to drive them. And in this particular example, I just want to give 2 examples of that our folks have worked on. This particular center is welding focused. And if you think about what happens in a lot of these metal deposition techniques, it involves melting metal. So guess what? All the welding stuff that people have been studying for the last 100 whatever years apply. And so they've looked at some really interesting things like, for instance, can you make a part which is tool steel down at the bottom and copper up at the top and has a constant gradient of composition as you go along? This is a great example of a partnership because the industry folks know exactly what kind of properties they would need from a part like this. Great hardness on one end, great thermal conductivity on the other end, for instance. And we have the tools to, first of all, build it, but second of all, to really analyze what's in there, to chop them open and do the right kind of analysis to figure out what's inside.
All right, forging ahead. America Makes. A lot of people have heard of America Makes. America Makes is a government-funded organization that takes money from the government and then hands it out to various people who apply for programs. In reality, if you want America Makes project, you have to have a quote-unquote gold member on your team. Gold members are the GEs and the big aerospace companies in general, folks like this. But these are multi-university, multi-company sort of teams. And there is always a very heavy R&D component. That's what I've highlighted over on the right. I'll explain what RAMP is in just a moment. But also, they have this workforce education and outreach component on the left-hand side. So they require that every project have this WEO component. And so even if your institution is not an R&D institution like Lehigh is, for instance, all of us are in the business of educating. And so this WEO opportunity is a way to get involved in these kinds of projects. And so RAMP is a subset of this. It's Additive Manufacturing in Pennsylvania. It's a chunk of America Makes money that was set aside specifically to support Pennsylvania industry-university interactions. The 2 universities that negotiated this were Carnegie Mellon and Lehigh. And so there's, over the last year and a half, there have been a number of different projects. I just want to quickly highlight 2 of them. Again, give you a sense of what kinds of things happen in these kinds of programs. I'll mention a polymer example, and I'll mention a metals example. So on the polymer end, here are the players. You can see there are 4 different companies, and their target, in this particular case, is very high performance materials. So polymers, very common commodity polymers, lots of people are printing with them. It's very hard to print with the polymers, I know you probably can't read those. The super high performance polymers are very hard to print with. So they tackled this material that Brian mentioned earlier called PEC. And what I wanted to give you a sense of is that when you team like this, every one of these companies provided a very critical component to this collaboration, whether it was materials expertise or processing expertise, what have you. Each one of these components was necessary. And Lehigh's role ultimately was to take the parts that were printed at 3D Systems and to do all of the polymer analysis, both mechanical and chemical and thermal afterwards. And so I can't give you the details of these because these all have a proprietary component to them. And so, by the way, that's part of these things, is IP of the companies is protected. So you participate in this, and even though you're working at a college or a university, there are parts of it that can remain hidden and parts of it that can be owned by you. So this is all good from that perspective. And the second and final one that I'll mention here is on the copper side. Brian mentioned copper is not a common thing to print, but if you're a company like TP Connectivity, who makes, among other things, electrical connectors, then electrical connectivity is really key. You might be interested in printing in a material like copper. And so one of my colleagues has been working with this binary material, copper tin. I should mention they also have a proprietary portion of this study that works with other copper alloys that are that have IP that is owned by TD. So we can't talk about those parts.
But this part was identified as a publishable component. And they've done things like, and don't worry if you don't understand this, it doesn't matter. They've done, the curves show the same material printed now, printed material but processed in 3 different ways. And the differences in the curves indicate that there are very different properties depending on the processing. This comes as no shock to people who know anything about materials, but the key is that none of these properties match what you would get exactly from a conventionally processed piece of copper. Okay. All right, I am going to finish then in my last minute or so by going back a little bit to the academic education side and to talk about entrepreneurship and teaching design and not just engineering, but the business side of things. So at Lehigh, as at many of the institutions, there's a big and growing emphasis on entrepreneurship. We have this thing called the Baker Institute, and a part of the academic program is TE, Technical Entrepreneurship. And for many years, we've run this thing called Integrated Product Development, IPD. They've now rebranded it. It's now the TE Capstone, but for all intents and purposes, it's the similar program to what's been run for a number of years. Here's how it works. There are industry partners who identify projects that they would like done, R&D projects, but not done by graduate students, but done by undergraduates, and done by teams of undergraduates. The industry partner provides some funding on the order of $10,000. They get 2 teams of undergraduates, about 5 to 8 students each, a mixture of materials students, bioengineers, mechanical engineers, business students, design students who tackle their problems. And again, IP owned by the company that's paying for it, but the students get an incredibly rich experience by working on real-world problems with guidance from industry. So I've just put up the names of 3 relatively recent projects that all used additive manufacturing in very different ways. On the left-hand side, this one here, biofab printing biologically active materials. Dresser Rand down at the bottom, printing metal impellers, so big things for pumps. And St. Luke's thinking broadly about healthcare. And I'll just show you, I have 2 slides left, just an example of what one of the St. Luke's teams came up with. So your typical wrist or hand brace, standard size and shape, kind of clamps on there, it's sweaty, not necessarily very lightweight, right, heavy. And so their question was, could you do something with additive manufacturing to make customized parts for the user a lot more breathable, a lot lighter? And so just one of the designs that one of the teams came up with is shown here. And as Brian was talking about earlier, this is a shape that you might not ever think about making by any other technology. And frankly, this was an application also that the students and the faculty probably never would have come up with either. So once again, an example of how a partnership can really lead to a rich experience for the academic side, but also ultimately may lead to a profitable or at least very interesting project on the industry side as well. So I'll stop there and take a question or 2 before we turn things over, if there are any. Yes?
The America Makes ramps.
Yep.
I work at Thaddeus Stevens, so it's a technology trade school.
Okay.
So you said something that made that sound of interest to my setting, and then your example seemed to go back to the Lehigh. So can you flesh that out? I lost you in that.
Okay, so America Makes has a membership sort of process. So various universities and companies become members, essentially buy into membership. And so they put up a big list of, they put up a call for proposals, right? And often there are general topic areas. So there is always an R&D component to every one of these because ultimately the companies, that's why they're investing in this. It's all about getting additive manufacturing into business. However, every one of these proposals must contain a workforce education and outreach component to it. And this year in particular, they have ramped up that portion of it. It's become a more important fraction of the total project.
So how would Stevens get rolled into that?
Right, so if you were to look at the America Wakes website, you will see who all the partner companies are. And I'm not sure the best way to open those doors, but quite often the partner companies are not in a great position to do that portion of the work. And they are looking for folks like maybe yourselves to come on board. And they love the idea, by the way, of educating the workforce of tomorrow. So if that is your business, then you may be in a very good position to fulfill that particular role for a member company with an R&D idea and no WEO idea. Okay? All right, I'm going to stop there. I think in the interest of time, make sure the next speaker can come on board. But I also will be here all day today and tomorrow if anybody wants to talk about any of these in more detail.
If you got a question while you're in transition, might as well take the question.
Okay, sure, why not? I'll unplug and...
I wanted to weigh in on American Makes. We are an industry, were an industry partner with American Makes for several years. I would just urge caution with American Makes and your IP. We eventually decided not to continue our investment in American Makes because their IP is your IP is very hard to protect in American Makes. And a lot of the companies that would like you very much to come in and share your IP with them are there to gather up your IP. So I would just urge a level of caution as an individual that has spent quite a bit of time with American Makes, that there are some issues with IP that you should be particularly aware of, and your students should be particularly aware of, that you're giving up a lot, even though they say you're not.
And that's absolutely true. We've seen that in their wording as well. And so that's one of the reasons why I think it's advantageous to understand that there are many different funding directions. There are some that I didn't put up there. There's a thing called DOTC if you're involved in certain types of military work, and there's lots of different organizations. Every single one of them has different IP language, right? So yeah, so you need to understand that as well.